This is Pre-Calc section 4.1, Rational Functions and Graphs. A rational expression is just a fraction that has a polynomial on the top and a polynomial on the bottom. Your most simple rational function is known as the reciprocal function, and it's the graph of y equals 1 over x shown over here on the right. You should remember from college algebra that you've got a vertical asymptote here in red, that is the y-axis, and that is the equation x equals 0. The horizontal asymptote is here in blue, that is the x-axis, and that is the equation y equals 0. Your domain is related to your vertical asymptote. Remember, x equals 0 is this line that your curve is not going to cross. That means we do not have a value at x equals 0. So our domain is all x such that x does not equal 0. Now, we want to write that, though, in interval notation. I write it this way first because I want you to see the relationship between the vertical asymptote and the domain. And for some people, having it written this way makes it easier to come up with the interval notation. So this is saying your domain is all x's except 0. So that means we come in from negative infinity to 0, union with 0 to infinity. Your range will be your y values, bottom to top. You are coming in from negative infinity, and it's coming all the way up to your horizontal asymptote. It's not crossing it, it is getting very close to the horizontal asymptote, so that is negative infinity, 0, union with 0 to infinity. What we're going to do now is use what we know about the basic reciprocal function and make transformations like we've learned before in college algebra. When you look at this right here, I hope you realize that this plus 4 out here is telling us that we need to move the graph up 4. So if we could, we would grab hold of these graphs and move them up 4. But instead of actually moving the graph, we're going to think about moving the asymptotes if necessary. The vertical asymptote of this graph is still x equals 0. The horizontal asymptote is no longer y equals 0, like shown here. You have moved the whole graph up 4, which means you have moved the horizontal asymptote up 4. Your horizontal asymptote is now y equals 4. So what I'm going to do here is move these asymptotes. The vertical asymptote is still x equals 0 here. Your horizontal asymptote is now y equals 4. Now notice one little thing about these graphs to make this fit on the page. These increments over here were 1, 2, 3. Here this is 5, 10, 15, so that's why it's not going to look exactly symmetrical. Then I can just draw this curve, knowing that the curve has to look like this in these regions. So I'm going to put my curve over here, and then this curve over here. And that is a reasonable sketch of this function. Now, use that function right there to name the domain. The domain is your x values. You are coming in from negative infinity, and you're going all the way over to the vertical asymptote, which is still 0, union with 0 to infinity. Notice that is the same domain we had on the original 1 over x. And the reason that domain hasn't changed from the 1 over x is because our vertical asymptote did not change. But take a look at your range. Your range is now different because your horizontal asymptote is in a different place. Your range is negative infinity up to that 4, union 4 to infinity. Another example, y equals 2 over x plus 1, and we're going to name the horizontal vertical asymptotes in the domain and the range. We're going to do it based on knowing that this is our graph of y equals 1 over x. You should know that x plus 1 tells you that you're going to move to the left 1. This whole graph will move to the left 1, which means the vertical asymptote needs to move to the left 1. So the vertical asymptote used to be at 0. Vertical asymptote used to be at 0, and it needs to be to the left 1. Now notice the increments here. These are tiny increments. This is really counting 5, 10, 15, so I'm right here moving left 1. There's nothing that tells me to make any kind of change on the horizontal asymptote. So the horizontal asymptote is still the x-axis. So all I have to do is draw in an approximation of this curve. So I'm going to come right on down past the asymptote, curving in, and the same thing on this side. Curving in, running along the asymptote. So the vertical asymptote is the line x equals -1. Now there's two ways to get that. One is the fact that we moved this asymptote, which was at 0, we moved to the left one. That's why it's -1. You also could go back old school like we did in college algebra in terms of here's your denominator of x plus 1, set that equal to 0 and solve. And we get x equals -1. So two ways to get that vertical asymptote. The horizontal asymptote, we are looking at the fact that we didn't move that at all. So the horizontal asymptote is still the line y equals 0. Your domain is going to be all x such that x does not equal -1. Remember, I'm still writing it in set builder notation just to tie the vertical asymptote and the domain together. But to rewrite this in interval notation, this will be -∞ all the way to -1, union with -1 out to infinity. The range is the same range it was for plain old y equals 1 over x. So this range is -∞ to 0, union with 0 to infinity. Now we're going to put two moves together here, which means both of our asymptotes are going to move a little bit. X plus 3 tells me I need to move to the left 3. Now when I say move to the left 3, you can think of it two ways. We're going to move the whole graph to the left 3. We're going to move the vertical asymptote to the left 3. And the other is -5 right here tells me that we need to go down 5. Same thing, I can take the whole graph down 5, or I can just think about moving the horizontal asymptote down 5. So taking these two asymptotes, I have the vertical asymptote needs to move to the left 3. The vertical asymptote was on the y-axis. Move it to the left 3. 1, 2, 3. Missed a little bit. 3. And move your horizontal asymptote. Move your horizontal asymptote, which used to be the x-axis, and move it down 5, which lands right here. So there's our little regions that we can draw our curve in, and the curve has to look like this same curve. It's just been relocated. And how has it been relocated? It has moved to the left 3 and down 5. So I can draw like this and like this. So the vertical asymptote is a line x equals -3 for two reasons. One, because we moved that vertical asymptote to the left 3, which lands at -3. Or you could take the denominator as is, set it equal to 0, and solve, and that's how we get x equals -3. The horizontal asymptote is now down here at y equals -5 because we moved it down 5. Your domain is from -∞ up to this red line, which is -3, union with -3 up to infinity. Now let's just be sure you understand why the domain is this. -3 is thrown out of the domain. So it's everything right up to -3, union with everything right after -3 to continue. Your range is coming in from -∞. It's going up to your horizontal asymptote, which is at -5. And then we skip over -5, and it goes from -5 to infinity. This is a graph of 1 over x squared, so it's a little different than 1 over x. But you can tell, looking at the picture, certain things. You can tell the vertical asymptote is at x equals 0. The horizontal asymptote is the x-axis, which is y equals 0. The domain of this is going to be from -∞ up to that vertical asymptote at 0, union from 0 to infinity. The range is above this horizontal asymptote, which is at 0, so it is just from 0 to infinity. So explain how the graph of the function f of x equals 1 over quantity x minus 4 squared can be obtained from this graph. So we're going to do what we did with the 1 over x graphs to start this video. So we need to look at where our vertical and horizontal asymptotes will be. X minus 4, quantity squared, tells us that we're going to move to the right 4. That means that vertical asymptote needs to go from the y-axis, and it's going to the right 4, which lands there. There's nothing that changes the horizontal asymptote, so this will still be along the x-axis. and there's our two asymptotes, and then I just need to draw my curve in so that it approximates this curve over here. So I'm coming here, and oops, and here. Now we want to give the domain and the range. While we're here, let's go ahead and name the asymptotes. Your vertical asymptote is the line x equals 4, because we moved to the right 4. Your horizontal asymptote is still the x-axis, which is y equals 0. Now to give the domain of this, the domain will be negative infinity up to that vertical asymptote, which is 4, union with 4 out to infinity. Your range, x-axis up, so your range is still 0, infinity. This next one is going to have us do two different changes. This plus 5 inside the parentheses tells me I need to move this to the left 5, and this minus 1 at the end tells me I need to move down 1. So I will take those asymptotes. I will take the vertical asymptote, which used to be on the y-axis, and move it to the left 5, which will land right there. Then I need to take the horizontal asymptote, which used to be on the x-axis, and move it down 1. So there's my asymptotes. All I have to do now is draw in my curve, which will look something like this. And my domain is from negative infinity to that vertical asymptote, which is negative 5, union negative 5 to infinity. And the range now, because the horizontal asymptote has dropped down to negative 1, the range is from negative 1 to infinity.